Hello everyone, I'm Mohit and today I'm starting my channel for, as you might have seen the title, Top Coding Interview Questions. So this is the first video and on this channel I'll be covering the very famous coding interview problems which are asked in the top tech companies like Amazon, Microsoft, Google, Facebook, and I'll be covering the problems which are asked in last 6 months. So I have the list from LeetCode. So whichever are asked most, those I'll be covering first. And so I'll be having different playlists for each of the companies, so you guys can see the videos. So without any further ado, let's get started. So the title is number of islands. What they're saying, given a 2D grid of map of ones, which is land, and zeros, which is water, count the number of islands. And an island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are surrounded by water. Okay, so this is a sample input. So basically what they're saying is wherever the connected ones are there in the all four directions, like top, bottom, left and right, so they will be considered land. And so here in this one, this part and this part, they all together construct one island. And yeah, even this one is also part of the island because it will be connected, it is connected from this particular one. Okay, so the number of islands in this particular input is 1. Okay, so let's see the another sample here. The connected ones are this and this, so these are connected horizontally and these two are connected vertically with these ones. So this is one island. I mean these two ones and these two ones, and then this is the second one. So on top, left, right, and bottom, nothing is there. Only zeros are there. So this is second one, and this is the third one. Okay, so how do we really approach this problem? So the approach will be we will start from any point which is 1, and thereafter we will try to go in all four directions and see how far we can go. So for example, we will let's take one example. Okay, so we have if we take the first input, it has 1 1 1 1 1, then okay, so this is our input. So what we will do, we will for example start from this point and we will go on all four directions like this, and we will keep on going until we are finding the ones. So from this one we went to this guy, then from here onwards we'll go on all four directions. So whichever is out of bounds, we will not process that particular cell, and the ones which are already processed, those also we will not process. So basically this will not get processed, this will not get processed. It will go over here and over here. So first if it goes here, then same process will continue, and it will from this particular cell, how many ones we can visit, we will process all of them and then we will make our count as 1. Okay, and if we talk about this particular example, in one particular call all of them will get processed. So as you might have already noticed, it's a recursive sort of function which is happening here. So we give one element and this will process. From here the recursion process will start and it will propagate all over the grid. So there are some things which we need to consider. don't visit the cells which are already visited. Don't visit zeros, and don't go out of bounds. So these are the things which we have to keep in our mind. So this was very high level, and let's see, since we talked about recursion, what kind of recursion tree can be created over here. So basically we will have some choices. Okay, so this particular part which I have mentioned, this will eventually come out as our base conditions, or we'll see how it comes. So our base condition in our recursive function, we have two things. One is the base condition, second is the choice diagram, or it is sort of the implementation of recursion tree. So on this channel, I am assuming you are pretty much familiar with most of the terminologies. Still, I'll be talking about them very briefly. So if we talk about recursion tree of this particular problem, how it might look like. So now if we have if we have come across one, so what are the possibilities after that? We have to process that one, right? So if this particular value is 1, then we will process it. If it is 0, then we will not process it. Okay, and if somehow we manage to find a way to just mark the all of the ones in one particular visit, so that we know they are already visited, and then start from the other ones. For example, let's take this example. Okay, so somehow what we want to do is, when we will start propagation from this particular one, then this will get visited. This in turn will mark this one as visited, then this one will mark this guy as visited, and then this guy will mark this one as visited, and then this will try to visit this. But somehow we want to keep track of how to know whether it is visited already or not. So what we can do is, as soon as we visit any of the element, we will just make it 0. And if even if we are able to get at least 1 then we will have some sort of count of islands. For example, initially the count is 0, and we will visit this, and from this, like I told, all 4 will get visited in one iteration, so count will become +1. Then so we started from this particular one, then we will see this one. Now this is already visited, see, so we will not process it. This is 0, this is 0 0, visited 0. So basically we will come across this guy, then we'll try to visit this, count will become 1 +1 basically, and we'll try to visit all its 4 directions, and we can't go anywhere, basically all of them are 0, so it will return immediately. Then we'll see this 0 0 0 can't visit, then we'll come across this guy, and from here we'll make our count 1 +1. Then we will propagate the uh, recursive function, and it will mark this one also as visited. Then basically we will go to next one, and this is already visited, so we won't do anything. So whatever remains in our count, which is 3, will be our answer. Okay, so let's see how it looks in the code. As you might have noticed, we'll somehow be iterating over this 2D array, marking the visited ones as 0 and doing some DFS in a recursive function to visit them. Okay, let's try to solve it. So this is my grid. So total, I'll be actually writing code in C#. So let me know in comments in which language do you guys prefer, because I basically work in C# mostly. The number of rows are 0. Number of columns are again not 0. So grid dot length, then number of columns will be grid 0 dot length. So before that, let's handle some base cases. For example, if number of rows are equals to 0, then return 0. In that case, there are no islands at all. Otherwise, we'll go ahead and get the number of columns, and now just loop over this 2D matrix. I equals to 0, I less than rows, I plus plus, j is equals to 0, j less than columns, j plus plus. Okay, so now we will check whether the cell which we are going to visit, whether it is a 1 or not, because only in case if it is 1, then we want to increase the count of islands. So we'll have one variable here, total islands, which will initially be 0. So on this channel, I'll be discussing the most optimal approach only. So you can just right away understand this particular approach and go ahead with this. So if in any interview, if you tell this approach, in most of the cases, there is no further optimization than this particular approach. There might be some here and there talks about maybe the trade-off of space complexity somewhere and increasing time complexity and vice versa. Okay, so coming back to the problem, if the cell which we are going to visit, only if it is a 1, then we want to do something, otherwise we'll just ignore it. So if grid of I comma j is equals to, so it's a character array, it equals to 1, then we want to process all the islands which are attached to this particular cell. Okay, so we will create a function process adjacent islands. So adjacent to which one? In this grid, this particular row and this particular column, which is actually I and j. So here basically we are passing our grid into this function and the cell in which the 1 is there. So here this is the row and this is the column index. So we'll process this particular cell, and once all of the cells are processed like this, then we want to increase our total islands count. Okay, and we'll just return total islands. Okay, so now in this function which we are going to write, we just have to take care of the part how to process all the adjacent islands. Okay, yeah, so let's write this function. So this function will just be processing the islands. Basically, what it will be doing, it will be marking the visited ones as 0, and visit all its neighbors, all its adjacent top, left, bottom, right. So this will not return anything, because we are not expecting anything from this function. We just want it to process. So what do we mean by processes? Just mark all the adjacent ones as 0, so that when this particular if condition is checked next time on line number 12, then it will be coming as 0, so it will not count it anymore. So that is the purpose of this function. So we first parameter was row, and then second parameter was the column of the cell. Okay, now as I told you, there are some base cases which we need to check, like this one. Don't visit the cells which are already visited. So this particular use case we have taken care over here itself. We are visiting only the ones which are 1, not 0. Now second one is don't visit 0. Okay, so yeah, it is again talking about this one. But yeah, let me rephrase the first one. First one say don't visit the cells which are already visited. So that part actually we will be taking care here by telling by marking that particular cell as 0. Okay, and don't go out of the bounds. Okay, so let's take care of these conditions. So what and all possibilities could be there? So the row, it could be less than 0, which is out of bounds if row is 0, or the column, it could be out of bounds if it is less than 0, or it could be uh, more than the row number of the row index, it could be more than the number of rows. So we need to take care of that part as well. So let's take this particular piece from here, number of rows and columns. I like to keep the things in variables to make it look clean code, so to say. Yeah, so if the row is greater than equals to rows, so let me give it a better name, row index, column index. Yeah, so fourth one, what it could be, if the column index is greater than equals to columns. Yeah, and yeah, why we are checking greater than equals to, we can even check equals to as well, because as soon as it goes equal we will stop processing it. And since it is a zero based indexing, that's why we are checking for equality. And the last one, which is the important one, is it will be if the cell which we are going to visit, it is not a 1. Okay, so if grid of row and column is not equals to 1, in that case also we don't want to do anything. So what we will do is we will just return Okay, so now if we have come here, what do we want to do now? We are at a place which is a valid one, and we want to process all its adjacent ones. So first, to process this particular cell, as we told, we will be marking it as uh, 0, because currently it is 1, right? So grid row and column is equals to 0. Now we want to process all its adjacent ones, so we will just call this method, and we will call this method 4 times with all the adjacent cells. Okay, so first parameter is very easy to tell, it is grid. Okay, uh, now what should we pass as the row index and column index? So let's just see quickly. So if we are at any particular cell, for example this one, okay, so whatever its row and column index is there, what we want to do is we want to go one row up. So up means it will be row -1 and same column. Okay, this is taken care of this cell. Now if we talk about this one, it will be row is same, just the column is one left one, so same row. So when I say row, it is referring to this one over here. Okay, yeah, this guy. So row is of this particular one's row, because this is the one which we are going to process. So yeah, this one is row, same row, and column -1. Yeah, and if we go down, so down is row will be incremented. Row will be incremented, and it's the same column. Then the right one will be same row, and column will be incremented, so column +1. So this had taken care of this guy. Okay, so with these 4 inputs, we will do the processing, and we'll be good to go after that. So if I put it here, so it's like a copy paste which we have to do now. So it is row -1, then column, then row and column -1, then row +1 and column, same column, and same row, column +1. Okay, so yeah, we have called it 4 times, and this will just do the processing. So even if it goes out of bounds somehow, then this particular piece of code will take care of that part, and will be good to go. Okay, so I think it looks good to me now. Let me try to run the code whether any compilation errors I left. Yes, I did. So operator cannot be applied to operands bool and integer. So first thing is this variable name is not row, it is row index. Yeah, this should be double equals to. Yeah, let's compile again. Oops, row does not exist. Here I missed it. Good now. No, it's a character array. Don't assign 0 directly. Put it in characters. Oh, finally. It is compiling, and let's submit the code. Yeah, it does pass. So we are good. So let me know in the comments about my way of teaching and how I can improve on the things. Okay, see you next time in the next video. Bye bye.